Combinational circuits. Combinational circuits are a type of digital logic circuit where the output is determined solely by the current inputs. These circuits do not have memory, meaning they do not depend on previous input states. The relationship between inputs and outputs is defined by logic gates, like AND, OR, and NOT. The output is generated immediately based on the input values, making these circuits fast and efficient for tasks that require immediate computation. Examples of combinational circuits include adders, multiplexers, decoders, and encoders. For instance, an adder is a combinational circuit used in calculators and computers to perform arithmetic addition. When two binary numbers are input into the adder, the circuit instantly produces the sum as the output. In real-life use, combinational circuits are essential in devices where decisions or calculations need to be made quickly without the need to store previous states. For example, in digital watches, combinational circuits determine the time display based on the input from the clock generator. Sequential circuits. Sequential circuits, on the other hand, are digital logic circuits where the output depends on both the current inputs and the history of past inputs. This means they have memory elements, typically in the form of flip-flops or latches, which store information about previous inputs. The output is not just a direct function of the current inputs, but also of the stored information, the circuit's state. These circuits are more complex than combinational circuits because they involve timing elements like clocks that control when the state of the circuit is updated. The most common types of sequential circuits include counters, shift registers, and finite state machines. Examples of sequential circuits include memory units in computers, where data needs to be stored and accessed over time, and in communication devices like mobile phones, where the circuit must maintain the state of a conversation or data transmission. In real-life use, sequential circuits are vital in systems that require memory or need to keep track of sequences of events. For example, in traffic light controllers, a sequential circuit ensures that the lights change in the correct order, red, green, yellow, and maintain the sequence even after interruptions. Key differences and applications. The primary difference between combinational and sequential circuits is the presence of memory. Combinational circuits are used for tasks that need immediate computation, while sequential circuits are employed in systems that require memory or a sequence of operations. In modern computing devices, both types of circuits are essential. For instance, in a microprocessor, combinational circuits handle the arithmetic and logical operations, while sequential circuits manage the control logic, storing instructions, and ensuring operations happen in the correct order. Questions and answers. Question: what is the main difference between combinational and sequential circuits? Answer: the main difference between combinational and sequential circuits is that combinational circuits do not have memory and their output depends only on the current inputs. In contrast, sequential circuits have memory and their output depends on both the current inputs and the previous state, past inputs. Question: give an example of a combinational circuit and explain its function. Answer: an example of a combinational circuit is a half adder. A half adder takes two single-bit binary numbers as input and produces two outputs, a sum and a carry. The sum is the result of the addition of the two bits, while the carry indicates if there was an overflow, i.e., if the sum exceeds one bit. Question: why are flip-flops used in sequential circuits? Answer: flip-flops are used in sequential circuits because they can store a single bit of information, acting as a memory element. This allows sequential circuits to maintain a state based on previous inputs, which is essential for tasks that require tracking sequences or storing data. Question: explain how a clock signal influences sequential circuits. Answer: in sequential circuits, A clock signal synchronizes the updating of the circuit's state. It determines when the memory elements, such as flip-flops, should store new information. This clock signal ensures that the circuit operates in a controlled and predictable manner, with state changes occurring at regular intervals. Question: what is the role of a multiplexer in combinational circuits? Answer: a multiplexer MUX is a combinational circuit that selects one of many input signals and forwards the selected input to a single output line. It uses control signals to determine which input to select. Multiplexers are widely used in data routing, where multiple data sources need to be directed to a single destination. Question: describe a real-life application of a sequential circuit. Answer: a real-life application of a sequential circuit is in an elevator control system. The system must remember the floors where buttons have been pressed, input, and ensure the elevator reaches these floors in sequence. The memory element, sequential circuit, tracks the sequence of floors, ensuring the elevator stops at each requested floor in the correct order. Question: what is a finite state machine, FSM, and how does it relate to sequential circuits? Answer: a finite state machine, FSM, is a model of computation used to design both combinational and sequential circuits. It consists of a finite number of states, transitions between these states, and actions. In the context of sequential circuits, an FSM helps to design systems where the output depends on the sequence of events, with the circuit moving from one state to another based on input conditions and its current state. Question: how does a decoder function in combinational circuits? Answer: a decoder is a combinational circuit that converts binary information from the n input lines into a maximum of 2 n unique output lines. Each output represents one of the possible combinations of the input bits. Decoders are commonly used in applications such as address decoding in memory devices, where they select a specific memory location based on the input address. Conclusion: these questions and answers provide a solid understanding of combinational and sequential circuits, which are fundamental concepts in digital electronics. Understanding these differences, functionalities, and applications is crucial for grasping how complex digital systems are designed and operated.